Configuration files and related topics. Configuration files control many aspects of a Linux system. Everything from system startup to a web server to the look and feel of your environment are controlled by configuration files. And we've already touched on some of them and their function, but in this video we're going to see more configuration files and deal with related topics like environment variables and run levels. So let's get started. Let's start out with the basics of configuration files. There's two main types of configuration files. There's user configuration files and there's system configuration files. The user configuration files typically reside in the user's home directory. Examples include things like the .bash rc file or the .emacs file. Okay, these are examples of user configuration files. And the user can edit their own configuration files, and the alteration of those files will only affect their environment. When I change my .emacs file, that changes my Emacs preferences, but it doesn't mess with anybody else's Emacs preferences. We classify all these user configuration files together, commonly with the name .files, okay, because they start with that period. And these files are basically hidden, right? Like if we do an ls on our home directory, we don't even see these files because they start with a period. And if we do an ls-a, then we'll see them. Okay, so that's exactly what we want out of configuration files. We know where they are, we know how to edit them, but they're not in the way all the time. They don't show up every time we do a listing. Now, system configuration files, on the other hand, are located in the etc directory and its subdirectories. And these configuration files are not duplicated. There's not one for every user in the system. There's one system configuration file for a web server. There's one system configuration file for the file system tables and things like that. Okay? And only the super user, only the administrator can edit these system configuration files, and that's because they affect everyone on the system. All right, so let's go out to the Linux screen and start looking at some of these configuration files and look at their formats and how to get them to do what we want them to do. So now let's take a look at some user configuration files. We're in my home directory here, so I'll just do an ls with the A option, and you'll see a whole bunch of user configuration files in here. Basically, everything that starts with a dot is one of these user configuration files, and you can pretty much tell what the configuration file controls just by its name. Okay, so the things that start with .bash here have to do with the bash shell. The things that start with .emacs have to do with the Emacs editor. The things that start with .gnome have to do with the GNOME environment, and so on. There's the Mozilla web browser, and you can see actually here that some of these things that are in blue here are not actually configuration files, but they're directories full of configuration files, and they're classified again just by what they configure. So all the stuff, all the web browser settings for Mozilla are in the .mozilla directory. Okay, and all the configuration files for the Sawfish window manager are in the .sawfish directory again. Okay, now you might be saying to yourself, well, wait, didn't a few videos ago, didn't you show us how to configure the Sawfish window manager through the graphical user interface, like through this main menu down here? And sure, I did. We went to programs, we went to settings, and we went into the Sawfish window manager, and we could alter any number of these things through the menu options. Okay, now that's perfectly valid, and if you say, well, I don't want to edit configuration files by hand, I'd rather use this user interface down here, that's perfectly valid. But if you're a system manager, a system administrator, then there's some real good reasons why you should know where these configuration files are and which ones control which things. Because say you're trying to give some settings, you're trying to give some configuration files to all the users in the system. Okay, they're all using the Sawfish window manager, and you want them to have some default settings so they can get, the full functionality out of that. Okay, well, instead of creating their account and then either giving them instructions on what to do or going to each account and going through those menu options, it's a lot easier to do some generic account, set it up the way you want, and then just copy all the configuration files that are related to what you're trying to accomplish, copy all those configuration files over to the user's directories, and then boom, they've got all those configuration files set. Okay, so these text files that hold all this information, it's a lot easier to copy those around than have to go to each single machine and go through the graphical user interface to set all these things that you want. Okay? Now that we're here talking about user configuration files, this would be a good time to step back and talk a little bit about environment variables. Environment variables basically keep track of the state of the system. Okay? Certain commands write to environment variables when they do something. Other commands read from environment variables, and then they make some output or act accordingly depending on the value of the environment variable. Let me try and make this a little bit more concrete for you. There's a command called env, and the env command will print out all your environment variables and their values. Okay, I'm going to pipe this through more because the list is going to be pretty long and I don't want it to scroll off the screen on us. Okay, so let me hit enter here and you'll see down the left hand side all these things over here in all capitals. These are the names of all the environment variables. Okay, and on the right side after the equal sign is the value of each environment variable. Now let's take one of these environment variables, let's take the PWD environment variable, and let's talk about it in pretty good detail. And I think you'll understand after that, so you'll get a general understanding of how environment variables work. Okay? Now first, let's go back and talk about the PWD command. Remember the PWD command? It prints your working directory. Okay? Now let's also talk about the CD command. The CD command changes your directory. But also the CD command writes to the PWD environment variable after it changes your directory, and it gives the PWD environment variable the value of the new directory that you're now in. Okay, so if I CD'd down into my scripts directory, for instance, okay, the CD command would change me into the scripts directory, and it would also change the value of the PWD environment variable to be home Perry scripts. Okay. That's how the CD command works. It changes your directory and then it writes to the PWD environment variable. Now let's talk about the PWD command. The PWD command prints your working directory, but how does it know that? It knows that because it goes to the PWD environment variable and it finds out its value, it gets that value, and then it prints that value out to the screen. Okay, so instead of typing the PWD command, you could just type N, and look at the PWD environment variable. That would be the exact same answer because that's all the PWD command does, is it looks at the PWD environment variable. Okay, so the CD command writes to that variable, the PWD command reads from that variable, and that's how it all works. And that's the function of that variable. Okay. And there's other commands too. There's a hostname command, and all the hostname command does is look at the hostname environment variable and print it out. Okay, and the name of my host is Nugget1. Okay, and there's lots of other environment variables. If I hit spacebar here to scroll down the screen, you can see the display environment variable. We talked about that a couple of videos ago when we were getting an X terminal from one machine to display on a different machine. We saw how to set the display variable to make that happen. Okay, there is also a shell variable which lists your current shell. There is a home directory. That's my home directory. That's the home variable. Okay, there's a terminal variable. It's called term. Okay, this one's actually kind of important because sometimes the things will mess up when you're using like a telnet connection, like a plain text-based connection. Okay, and in those cases when you're using like a plain text-based connection, check your term variable and make sure the term is set to something like VT100 or VT220 or something like that. And these are names for archaic terminals back in the day, before there were mice and before there were like scroll bars and stuff over here on the right, things like that, back when there were just plain text terminals. Because that's what your telnet window is, right? It's just a plain text terminal. There's no mouse functionality, there's no scroll bars or anything. And so these types of terminals should have the term variable set to something like VT100. And I'll show you how to change these environment variables in a couple minutes. And then finally, the last environment variable I want to talk about is probably the most important environment variable, the path environment variable. The path environment variable tells the operating system where to look for executable programs. So when I type some command, like say I'm down here at the command line and I type, PWD for instance, okay? Well, this is a command, right? This is an executable command. Well, what the operating system does is it says, okay, you want to run the PWD command, I'm going to look in the bin directory and see if there's one in there to run. And if there's none in there to run, then it's going to look in user bin and it's going to see if there's one in there to run. And if it's not in there, then it's going to look in user bin X11 and so on. Okay? Now, until it finds it, it's going to keep going through this list until it finds a PWD command to execute. And it goes all the way through the list and it doesn't find one, it'll say, sorry, I can't find a PWD command. Even if there is one out there, if the directory that it's in is not in your path, it won't find it. Okay, so I referred many times throughout these videos, and I've shown you also how to set your path so that all the correct directories are in it. If you put in some new piece of software and you put it in some different directory, you better add that to your path. Okay, and another thing to note here is that everything that it does, whenever it looks for a command, it looks in order. Okay, it doesn't skip around here. So it's going to, this is the most important directory in some sense. This is the second most important directory. This is next, and so on. Okay, so if you create some program and you put it in home Perry bin, right? And because it's for you, it's not for anybody else, okay? But if you named it the same as some name of some executable program in user bin, you would actually, it would be really hard to run this, because every time you went to run it, it would run the one up in user bin, okay? And that's where this command which comes in, right? There's a command which that shows you which PWD you're running, okay? Maybe there's a bunch of different versions of it out there, but it'll show you which one you're running, and basically the one that you're running is the one that's first in your path. So here it's /bin/pwd. Even if there was one in user bin, that's not the one that's going to be run, because there's one in /bin. Okay, so the which command just sort of looks for that, tells you which one it's finding, which one is the first one that it found in the order that's in your path variable. Now let me show you actually how to set an environment variable explicitly. Okay, and we've done this before with the display environment variable or with the path environment variable. Let me explain it to you again, and maybe it'll sink in more since we've been talking more about environment variables explicitly here. Okay, so one of the ways to do it is just to give the environment variable, give an equal sign, and set it equal to what you want. So like I was saying, sometimes you want to set term equal to VT100 when you're using a telnet connection, okay, if things are going wrong. All right, so term equals VT100 will do that, and then what you do is you say export term. Now this makes like the term variable that you just set sort of take effect, okay? And now if you do an env again, you'll see down here the term variable is now set to VT100, okay? Now let me show you the other syntax to set these. You can do it all in one line. You could say export term equals, and let me change it back to what it was, xterm. Okay, so here you just say export, you do it all in one line. Export followed by the environment variable name followed by the value that you want to give it, and you do that, and again I can type env, and you'll see again that the term variable has been changed. This time it's been changed back to xterm. Okay? Environment variables can be set for everyone in the system up in a file called the etc profile file. Okay, so if we look in this file, here you'll see an example, the path variable is being set here. Okay, now there's a few if statements here, but basically let me just explain what this line does. Okay, what this is doing is it says take the path variable and set it equal to this thing over here on the right, and what's over here on the right is the /sbin directory, and the colon says append that on to what the path is equal to already. Okay, so this says add sbin to my path. That's basically what this line of code says. This line of code says add user sbin to my path. This line of code says add user local sbin to my path, and so on. Okay, so this is what's happening here. This is how you set up the path environment variable for everyone on the system. You do that in the etc profile file. Okay, now if you want to set something just for yourself, like you want to add something onto your particular path but nobody else's path, you would do that in your own user configuration files. So let me quit out of the etc profile file here, and let's look at the bash profile. Okay, this is where you would change your own personal path. So if we look at this file, you'll see in here I set my own path here. I said, okay, keep the path that's already there, but append onto that $home/bin. $home is another environment variable that's equal to home Perry. Okay, so this environment variable says add home Perry bin onto my path and add it onto the end here. Okay, you notice that, and then I'm adding it onto the end. So I want to have all these path places take effect before home Perry bin. Now let's poke around and look at some system configuration files and the startup scripts and that kind of stuff. And remember, I told you that stuff was in the etc directory and its subdirectories. So let me switch over to be the root user here so we can poke around and see everything that we want. And let's go to the heart of it all. Let's go to the /etc directory, and we'll do an ls here. And a bunch of stuff just scrolled by the screen. Let's go back and look at some of that. There's all sorts of files in the etc directory that we've already dealt with. Right, like resolve.conf, which was the file that where we listed all of our name servers for our internet access, that kind of stuff. There's the etc password file, the etc shadow file. There's the etc group file. We saw all those things. There's the host allow and host deny file. That stuff, okay, we've seen that. There's the X11 directory, which sets up, the configuration files for X Windows. The PPP directory, which is where you would configure the point-to-point protocol. Okay, so lots and lots of stuff is in here. What I want to do now is go to the rc.d directory, which on Red Hat is where the system startup scripts reside, and we'll talk a little bit about run levels and how all this, the startup works and so on. So let's go down into the rc.d directory and look around a little bit. There's a few subdirectories in here, rc0 through rc6, that we'll talk about in a few minutes. And then there's rc local, a script, and rc sysinit, which is also another script. rc sysinit is the system startup script for Red Hat. For other systems, it might not be in the etc rc.d directory, it might be in the etc init.d directory, it might not actually be called rc.sysinit, it might be called rc something else, or it might be called sysinit.rc or something like that. Okay, poke around in your system, look in the etc rc.d directory or init.d directory first and look for it. Now the rc.sysinit script that starts up the system is a beast. I mean, this thing is like 50 pages long, okay? And don't mess with this script. Leave it alone, because there's, if you try and pull something out of the script or add something in the middle or something else probably depends on that, and you might mess everything up and your system won't boot. Okay? The way to do it is if you want to add something to your scripts, add it to the rc.local script. Okay? And if we look at that script, okay, you'll see that this is executed after all the other init scripts. Okay, you can put all your initialization stuff in here, and nothing that gets done prior to this is going to get messed up by putting it in rc local. Okay, rc sysinit does everything from mounting disks to file system checks to loading fonts so you can see characters on your screen and everything like that. Okay, and you don't want to mess this script up. All right, so let's take a little aside and talk a little bit about run levels, and then we'll come back here and look at these various directories. Now let's talk about run levels a little bit. There's different run levels in the computer, 0 through 6. And each run level represents sort of a different state of the system. Run level 0 is the off state. There's nothing running there, so it shouldn't even be called a run level. Then there's run level 1, sometimes also referred to as run level S. That's not a 5, okay? So run level 1 is single user mode. This is what you would be in if you were like recompiling the kernel or trying to recover some files off of disks or something. Something where you don't want anyone else logged on the system, and you might have to do some reboots and things like that. You don't want anyone else on the system, so you would be in run level 1. Run level 2 would be a multi-user mode. It would have all the functionality out there except for networking. Run level 3 would have multi-user mode with networking. It's like sort of one step up. Run level 4 varies from vendor to vendor, what exactly is running at run level 4. You can check out your system and see what's there. Run level 5 has all the functionality with the X Windows environment. And then run level 6 causes an automatic shutdown and a reboot. Okay? Now, what happens is when that startup script takes over, basically the first thing it does is it checks and sees which run level it's going to go to. And it looks in some file. I'll show you how it looks for that. And then it determines which run level it goes to, and then there's a startup script for each of these run levels. And the main startup script calls the independent startup script, so there's like RC1, RC2, RC3, RC4, and so on, and each of those scripts carries out the actions for that run level. Okay? And you can get whatever services, extra services you want running at each run level by altering those scripts, and I'll show you how to do that in a couple seconds too. So each of these directories, RC0, RC1 up to RC6, corresponds to a particular run level. And each of these directories has information in it that the startup script is going to use to decide what services to start and stop to enter that run level. What services will be running when the run level is entered. Okay? Let's look at one of these directories. Let's look at RC1, okay? And by contrast, we'll also look at RC3 in a second. But let's talk about this for a second. There's two kinds of files in all of these RC directories, okay? There's files that start with K, and there's files that start with S. Okay, and you can see the S ones over here, and all the K ones are up front. Okay, the files that start with K correspond to services that must be killed to enter this run level. So if the NFS service is running, then it should be killed to enter run level 1. That's what this says. Okay, if the LPD, the line printer daemon, is running, it should be killed to enter run level 1. Okay. Now the S corresponds to services that should be started if they're not running already. So the service single and the service key table should be started to enter run level 1. Now let's contrast this with run level 3. Okay? And you'll see here that much fewer services are killed and many more services are started. Okay, and they just relate, you know, like we said, RC1 relates to run level 1, which is single user mode, and RC3.g relates to multi-user mode with networking. So obviously, more services will have to be started to have multi-user mode with networking than single user mode. Okay, now if you wanted to change something here, like say you wanted to start some service in run level 1 or have some other service killed in run level 3, then what you would do is you would change the S, the leading S on this file, to a K, and then that would kill that service. And you have to be careful of one more thing, that there's this sequence number after the letter. Okay, so K03, K20, K20, K46, K50. K3 is going to be done first, then the K20s, then the K46, then the K50, and so on. This is just an ordering for the system to know which order to kill things. And the same for the S's. This is the order to start things. So if you're going to add something to this list to start it up when you go into run level 3, be careful to understand what it depends on and make sure that it starts after the stuff that it depends on. Okay? So that's the structure of all these RC directories. They're basically all the same in basic structure. They have some K's in the front, some files corresponding to K, which corresponds to killing services, and files that start with S, which corresponds to services that must be started to enter that run level. Now another important file in this whole startup process is a file up in the etc directory called init tab. Okay, this file is just another piece of the whole startup puzzle. Okay, and up in the front of the file it describes all the different run levels, and you can see here that it says level 4 is unused in Redhat. Like I said, that level 4 varies from system to system. And one of the next things it shows is what the default run level for the system should be, and here it's saying that the default run level for this system is run level 5, which is the multi-user mode with X Windows. Now, if you want to change the run level permanently, you just go into here and you change this 5 to 3 or 2 or whatever you want to change it to, and then that will be the run level for your system once you shut down the system and reboot. Okay, so and the system will always boot into that run level until you change the number in the init tab file. And as you go down through this file, you'll see stuff, what should start at level 0, what should start at level 1, and so on down here. This should be run in every run level, it's saying. Down below, you'll see that you know, there's some Getty programs, these get TTY programs. These are just text-based login programs. Okay, and what this really is like, you know, when you see that login prompt for you to type, that's actually a program running. And it says, okay, give me your login name, you give it your login name, you give it the password, and then it runs a little program that verifies to make sure your login name and password are valid, and then it logs you onto the system. So that little thing that prompts you for your login and your password is a program that's called a Getty or a get TTY, and that's running at every run level. Okay, you need that whether you're in single user mode or multi-user mode with X Windows and so on. Now something that you might want to do actually is change the run level temporarily instead of change it permanently like we saw that you could do in the init tab file. So to change it temporarily, use the teleinit command. Okay, and what you would do is you would follow teleinit by the number of the run level that you want to switch to. Now if I hit enter here, what would happen is I would lose my X Windows screen here. I would actually be logged off, and then I would get a login prompt like that Getty prompt on a text-based screen. I would log in and I would just have text access to my computer. I would have no windows, no mouse, none of that stuff. Okay, that's what teleinit 3 would do. I won't do it because the screen's really ugly and I don't want to show you all that stuff. I just want to show you how you would do this. This is a really useful trick to have up your sleeve when you're learning X Windows and you're messing with the configuration files. Because a lot of times what might happen is you mess with the configuration file and X Windows won't start anymore, but it also doesn't just like end gracefully. It like tries to start, it fails, it flickers, it tries to start again, it flickers and it fails, and this is just a mess. Okay, and you won't be able to get control back of your computer, unfortunately. And so what you should do in that case, if you've really messed things up with the configuration files, is log into your computer from a remote computer, become the super user, and then type teleinit 3 or teleinit 2 or something to get it to a run level that doesn't run X Windows. So then X Windows would automatically be shut down. Now, to shut down your computer altogether, don't just type teleinit 0, okay? And instead use a command called shutdown. And let's look at the man page for shutdown. So man page, or the shutdown command, brings down the system. It brings down the system in a nice way. It spins down the disks, it makes sure everything's closed up correctly, and so on. Okay, so this is the way that you want to bring down your system. And there's all sorts of options for shutdown. You know, the -K option says don't really shut down, only send the warning message to everybody. The -T option says how long in between the warning message and the actual shutdown. Okay, the -R option says to reboot after shutdown, and so on. Okay, and there's all sorts of things. You can force a filed system check on the reboot. You can cancel an already running shutdown. Okay, and so on. All right, so this just kind of gives you the option of shutting down your system. It warns everybody that's logged onto your system. You can give some warning message, and you can do all sorts of options like rebooting the system, file system checks, and so on. And this is the way you want to shut down your system, not with telnet 0. Let's talk about one more thing before we wrap up. We've seen that if we change the run level from, for instance, run level 5 to run level 2, a bunch of services are going to stop. Namely, those services that are not scheduled to run in run level 2 but were running in run level 5. But changing the run level is kind of an extreme measure just to stop some service. And instead, you can do what I'm going to show you right now to stop one service in particular. So I'm already in the etc directory, so let me go down to the init.d subdirectory of etc and do an ls there. And you'll see a bunch of scripts here. Now these scripts all control some particular service. The lpd script controls the line printer daemon. The sendmail script controls the sendmail program. The zinetd script controls the zinetd daemon. Okay? Now these scripts can all control those particular services, and you can stop, start, and restart those services with very simple commands. Okay? So now if you weren't in this directory, the way that you would do this is you give the full path name, like etc init.d slash, say, lpd. And say we want to stop that service. So you give the lpd script the stop command. Okay, just like this. You hit enter there, and it says stopping lpd, and then it says, okay, it's stopped. All right? Now, if you want to start that service, you know, you can do it also, you know, because I'm in this directory, I can also do it with like the // like we did with our shell scripts. So I could say /lpd, and I could say start. Okay? And that starts the lpd service. Okay? And there's one more command that you can do, is called a restart. It'll stop and then automatically restart. Sometimes the service just kind of hangs. It looks like it's running, but it's not actually working. And so you just want to stop it, but you'll want to automatically restart it. And in that case, you can just use the restart command to save you from typing stop and then start. So I do that, and it says stopping LPD, starting LPD, and so on. Okay, so any of these scripts in here can be stop, started, or restarted in this kind of a format. And this is the way that you want to do it if you want to stop one particular service. All right, well, it's time to wrap up another nugget. The main topic of this nugget was configuration files. We talked about user configuration files and system configuration files. And remember, we also call user configuration files dot files because they start with a period. So if you see something in a text or on the web about the dot file, they're talking about user configuration files. Then we moved on and talked about system configuration files, and most of those are in the etc directory and its subdirectories. And we talked about what the startup scripts were, what other kinds of scripts they called, what configuration files they used. And then in that discussion, we threw in a discussion of environment variables, and also learned about the etc profile file, which was the place where you set environment variables for the system at large. And we also talked about run levels because they were important to understand some of the system startup scripts and what they were calling, where it's based on what run level we were in. Well, I hope you found this nugget informative, and thanks again for viewing.